Hi everyone, my name is V. Pavansai Srinivas from CSITB section. My roll number is C7. Today's my topic is electrical properties of polymers. Subject chemistry. Polymers. Polymers are long chain giant organic molecules are assembled from many smaller molecules called monomers. The following are the reasons for extensive use of polymers. First one, most of the polymers are non-toxic and safe to use. Second one, they have low densities like in weight, so transportation polymers will be easy. Third one, they possess good mechanical strength. Fourth one, these are resistant to corrosion and will not absorb moisture when exposed to the atmosphere. Fifth one, these can function as a good thermal and electrical insulators. Sixth one, these can be molded and fabricated easily. Seventh one, they possess aesthetic colors. Following image contains monomers. Many small molecules combine to form one large molecule called polymer. It is also interesting to note that many carbohydrates, proteins and enzymes, DNA and RNA are natural polymers. Polymers can be defined as the large molecules formed by the linkage of small molecules called monomers. In Greek language, poly means many and mer means units. Example, polythene, NCH2 double bond CH2. Polymerization to give CH2 bond CH2 whole N. Here we goes to the topic. Electrical properties of polymers. Introduction. For the last many decades, tremendous increase in the usage of polymers and polymer-based materials can be seen for various applications. One of the important areas in the usage of polymers for electrical appliances. Polymers having high dielectric constants can be used for applications such as film capacitors, artificial muzzle, while the one with low dielectric constants are used in the field of capacitors and dielectric materials. It is indeed to present experimental results of discharge development of voids in polymeric materials over a long high voltage stressing periods. When the initial deterioration of insulation material starts developing, the PD patterns and degradation over different void dimensions and arrangements will be reported in the order to determine the pattern variation due to the electric field and their effect on the chemistry and composition of metals. This is the example of the electric property of polymer. Size and distribution of voids in polymers are very important in the performance of polymers. Internal and coronal partial discharge are the most common defects that affect the polymeric insulation used for high voltage insulation system. Polymer chemistry. In recent time, high dielectric materials and low dielectric materials are used for capacitors. Table 1 shows the high dielectric values and table 2 shows the low dielectric values. For example, BaTiO3 has 1700 dielectric permeability, but in table 2, non-fluorinated aromatic polymides consist of 3.2 to 3.6 dielectric permeability. It shows that differences between the dielectric properties of the polymers. Polynitriles. The nitrile polymers is composed of three monomers, namely alkylonitrile, butadiene, and carboxylic acid. The properties of the monomers depends on the composition and attachment of the monomers. Next, silicon containing dielectric materials. Silicons containing polymers are made up of silicoxane unit means alternating chain of silicon and oxygen atoms combined with the carbon and hydrogen. The materials have excellent heat resistant properties and they are used as insulators, lubricants, adhesive and sealants in electrical thermals and pharmaceutical industries. Polymers used in high voltage applications. Polymeric materials can be found naturally or synthetically thanks to chemical processes conducted in laboratories. Paper, wood, wax, leather, cellulose, and rubber are the examples of natural polymers, while the phenyl formaldehyde, commonly known as bakelite, is a good example of polymer synthesized in laboratory. In several applications, simple polymers with some additives can be used for power cables, transformers, insulators, and rotating machines. Thermal characteristics and physical and chemical structures, mechanical and electrical behavior of among others are shown in the table 3. These are the types of polymers which are used in electrical appliances. Polymer type: thermoplastics material, polyethylene, cables, polyvinyl chloride, commonly known as PVC, used in transformers. Polymer type: thermosets, used material, polyester resin, used in rotating machines. Polymer type: elastomers, material, silicon, used in polymer insulators. And these are the materials used as electrical insulators, cables, transformers, etc. Aging in the polymer insulation systems. The aging process present in the insulation systems of an electric machine or equipment can be defined as the irreversible changes of their intrinsic properties due to action by one or several degradation mechanisms or factors. Insulation system has four types of mechanism: thermal mechanism, environment mechanism, electrical mechanism, mechanical mechanism. It has thermal mechanism consists of two types: oxidation or hydrolysis. Environment mechanism consists of three types: gases, acids, pressure, radiation. Electrical consists of three types: partial discharges, over voltage, tracking. Mechanical consists of three types: cracking, tension, vibrations. Electrical stress. The presence of non-uniform fields in polymeric insulation is necessary condition for dielectrical aging under normal voltage or high over voltage conditions. When high voltage is applied, space charge is formed inside the dielectric materials, which causes the aging of the polymer. Thermal stress. It can be considered another important stress factor in polymer insulation systems, since the increase of temperature and heat cycle accelerate most of the degradation process, such as oxidation, hydrolysis, chemical attack, and mechanical creep. Environment stress. It can be identified as one of the main reasons of failure in polymeric insulation. Among the main factors of environment stress, the author would like to highlight sunlight, gamma ray, and X ray radiation, salt and dust contamination, acid rainfall, and even pressure. Second one, mechanical stress. For most of the electrical equipment, mainly electric machines, the mechanical stress can appear in the form of compression, tension, bending, vibration, and impact. All of these factors acts directly on the insulation, leadingly in many cases to fissures in the bulk of the materials or at the interfaces between materials of the insulation systems. These are the stress graphs which are represented like this. Partial discharges in polymeric insulation, undergone cables, cross-linked polyethylene, known as XLPV, is commonly applied as the insulation material for high voltage underground cables. XLPV possesses high excellent dielectric properties and can withstand high voltages up to 380 kilovolts. As stated previously, one major PD defect in HV insulation is the void. It is necessary to understand possible internal PD activity over time in order to ascertain whether different void PD patterns vary in uniqueness and characteristics. It is also important to understand different void degradation characteristics and how they affect the lifeline of HLV apparatus. These are the XLVP voids. The first one says that the sample set shown has a dielectric bond void at the middle of the PET layer. Second one shows the electric bounded void. This is about the electrical properties of polymers. Thank you for the giving wonderful opportunity.